Okay, so earlier we looked at Euclid's definitions, Euclid's axioms, four of those axioms. Now let us move on to three more of those axioms and then five postulates, five postulates. So the fifth axiom states that the whole is greater than the part. So which is something like if I have one full apple or the whole of an apple, it will always be greater than part of it, which is again, common sense. If you break something down into pieces, then usually that whole thing will be always be greater than the small broken part. So that is what is meant by the fifth axiom. It states the whole is greater than the part. Okay. Now the sixth axiom states things which are double of the same thing are equal to one another. Suppose I have a small line segment and I have another line segment which is the double of the black line. Then again I have a third line which is also double of the black line. So things which are double of the same thing will be equal to one another. So something like if this black line is 5 centimeter long, then the red line will be 10 centimeters long. Now again, the black line is 5 centimeters long, and since the blue line is also double of the black line, that will also be 10 centimeters. So on the left side we have a 10 centimeter long line, on the right side also we have a 10 centimeter long line. So they are equal to one another. So things which are double of the same thing are equal to one another. So that is the sixth axiom. Now the seventh axiom is this said in the opposite sense. Things which are halves of the same thing are equal to one another. So suppose I have a black line, and this black line is half of the red line. Okay? And suppose I have a third line, a blue line, which is also exactly half of the red line. So the seventh axiom says things which are half of the halves of the same thing, they are equal to 1. So for example, let's say the red line is 10 centimeters long. And then since the black line is half of the red line, this will be 5 centimeters. Again, the blue line is half of the red line. So the blue line is also 5 centimeters long. So we have two lines that are 5 centimeters long. So we can say they are equal to one another. So that is what we mean when we say things which are halves of the same thing are equal to one another. So that concludes, Euclid's axioms. So now we move on to Euclid's postulates. So we saw postulates are also universal truths, but when they are related to geometry, we call them as postulates. When they are in a general sense, universal truths, they are called as axioms. So let us look at the five postulates of Euclid. So your Euclids are, postulates are universal truths which are related to geometry. So the first postulate says a straight line may be drawn from any one point to any another point. So if I have one point, okay, and if I have another point, between these 2 points, I can draw a straight line. Okay, suppose I take this point and I take a point anywhere else, it could be anywhere. I can always draw a straight line between these 2 points. Another way of saying this is if I am given two distinct points, there is always a unique line that passes through them. Okay. So suppose I'm taking two distinct points. Now through one point I can have many infinite number of lines passing through them. But through 2 points there is always a unique line that passes through these 2 points. Okay. So given two distinct points, I can have there is always a unique line that passes through these 2 points. But for a single point, you can have infinite number of lines passing through a given point. The second postulate says a terminated line can be produced indefinitely. So, if this is a terminated line, that is something, a line that has been stopped at A and B. But the Euclid's second postulate states it can be reduced or extended indefinitely. Okay, so a terminated line can be reduced or extended indefinitely in both directions. Third postulate says a circle can be drawn with any radius and any center. So I can choose any point to be center of a circle. I can choose any radius. Could be any line. It can be as small as this or as big as that. So I can choose any point to be center, any line to be radius, and make a circle. So that's the third postulate. A circle can be drawn with any center and any radius. The fourth postulate says all right angles are equal to one another. So suppose I have a rectangle and I have a right angle. Okay. Now this right angle will be equal to the right angle in this L shape. Okay. It is also common sense because both these angles are 90 degrees. So the angle here is the same as the angle. So all right angles are equal to one. The fifth postulate is the longest, and it is a bit tricky to understand, but if we read it line by line, it is very easy to understand. If a straight line falling on two straight lines, okay, so we have a straight line, okay, PQ, or this one, falling on two other straight lines, okay, that is lines AB and C. Okay. So if a straight line falling on two straight lines makes the interior angles on the same side of it, okay, so these are the interior angles: angle APQ, angle CQP. Okay, these are two interior angles. Another two interior angles are angle BPQ, okay, this angle BPQ, and angle PQD, this angle. So these are two interior angles. So if a straight line falling on two straight lines makes the interior angles on the same side of it. So we're talking about the interior angles on the same side of the straight line, okay? So we're talking about angle 1 and angle 2, not angle 1 and the angle PQD. Okay, so we're talking about interior angles on the same side taken together. That is, when you add these interior angles taken together, less than two right angles. So we know that one right angle is 90 degrees. So if the straight line makes interior angles on the same side taken together less than two right angles. So taken together means sum. So if the interior angles on the same side, if their sum is less than 180 degrees, that is two right angles, then the two straight lines, if produced indefinitely, that is, if I produce a if I produce the lines A, B, and C, D indefinitely, okay, if produced indefinitely, it will meet on the side on which the sum of the angles is less than two right angles. So you can imagine these when extended, they will meet somewhere over here. Okay, so they will meet on that side on which the sum of the angles is less than two right angles. So here the sum will be less than 180 degree or two right angles. So this is the side where the sum of the angles is less than two right angles. So here the sum of the angles is greater than two right angles. So I hope you got the idea. If a straight line falling on two straight lines, so we have a straight line PQ falling on two straight lines, AB and CD, makes the interior angles on the same side taken together less than two right angles. So here we have, interior angles on the same side which is less than two right angles, that is, which is less than 180 degrees. Okay. And if it is produced, if these lines are produced indefinitely, that is, if we extend these two lines, okay, they will meet on that side on which the sum of the angles is less than two right angles. Okay. So these lines will meet on the side in which the sum of the angles is less than two right angles. Okay. So that is the first. So this is one of the easiest chapters in this year's course. I would request you and encourage you to try out the examples and do. There is just one exercise, exercise 5.1. If you have any doubts, please you can WhatsApp me in this number anytime you want, or you can send me an email at this mail ID. Kindly do the examples and the exercises in your rough work and kindly send